Now we're going to look at these two vectors, 3, 5, and a1, and we're going to figure out which value of a, or values of a, will make these two vectors parallel, and which values of a will make the two vectors perpendicular or orthogonal. So in order for the vectors to be parallel, what needs to happen is that one of the vectors needs to be a constant times the other. Well, if you'll notice, this y component is 5, this y component is 1. This y component is 5 times this component. So what we need is for this vector to be 5 times this vector. So 3, 5 needs to be equal to 5 times a1. At least then the y components will match. So if you multiply this out, you're going to get 3, 5 equals 5a and 5. The y components match. The x components must also match. So 3 equals 5a. That tells us that a is 3/5. Now, what about for the vectors to be perpendicular? Well, that means the dot product of the two vectors needs to be 0. The dot product is going to be 3a plus 5. And if that's 0, that tells us that a is equal to, I believe, negative 5/3. So now we have our second problem labeled number 6, and in it we are supposed to find the angle that this vector makes with the negative z-axis. So we're going to use the cosine formula that we've used before. What we need is a vector parallel to the negative z-axis. So that would be maybe 0, 0, minus 1, negative 1 in the z direction, 0 in all the other directions. So the cosine of the angle between the two vectors is going to be equal to the cosine of the angle we're interested in. So we take the dot product and divide that by the product of the magnitudes of these two vectors. And I think when we've worked this one before, this turned out to be 146, square root of 146. And then that is a unit vector, so its magnitude is 1. And let's see, I think this turns out to be negative 3 over the square root of 146. And so the angle theta will be the arc cosine, or inverse cosine if you prefer, of negative 3 over the square root of 146. In number 7, we are asked to find the equations of lines. Well, in part A, we want the equation of a line perpendicular to the vector 3, 4 that passes through the origin. And in part B, we want the line parallel to the vector 3, 4. Okay, so since these lines pass through the origin, let's use the form y equals mx plus b. The m is the slope, the b is the y-intercept. In this case, b is 0, and so we'll get y equals mx. Now, I don't think either one of these lines is going to be one where the slope is undefined, so we can get away with using this formula. Right? This will work. This will give us the equation of any line that passes through the origin, except for a vertical line, which would be coincident with the y-axis. And we don't have that here. All right, so what we need to do is figure out the slope for each one of these vectors, or the slope of a line that would be parallel to each of these vectors. So we want to think of these as an x and a y. So if we start at one point, we're going to go over 3 and up 4. That's the vector. Now that's going to give us a slope of 4/3. So for part A, our equation will just be y equals 4/3 x. Now for part B, we want a line that is perpendicular to this line. So you might remember that there's a relationship between the slopes of perpendicular lines. Their slopes are negative reciprocals. So if this line has slope m, then the line that is any line that is perpendicular to it will have a slope of negative 1 over n. You take the reciprocal and you change the sign. So instead of having a slope of 4/3, this new line in part B will have a slope of negative 3/4. We just took the reciprocal of the slope we had up here and changed the sign.